Okay, today we are going to cover on the topics laws of indices. So all these are actually the laws of indices that will be covered shortly. So all this, to start off with, I would like to go to the basic, which is a to the power of m. So a is what you know as the base, and m is actually the power. Okay, so in the laws of indices, you must know base, whereby you will write it bigger, m superscript, you will do it a smaller font. Okay, so what does this mean? Now in primary school, you learn about 2 times 2 equals 4. 2 times 2 times 2 times 2 equals 16. Okay, now when you learn indices, what you will do is you represent the number of times it appears. This is the base, so this is the number that appears, so it's actually 2. How many times does it appear? It appears 2 times. Okay, so it's indicated by this. So what about this? So the number that appeared is 2. How many times does it appear? 1, 2, 3, 4. So the power is 4. Okay, let's go through another example. So if I have 5 times 5 times 5, so the base will be the number that is repeated, which is 5, and then the power will be 3. Okay, one more example. 9 times 9 times 9, answer 9 cubed. Okay, so if you understand in numerical form, this is how it's represented. A represents the base. In this case, the A is 2 and the M is 4. So, the A is 2, M is 2. Okay, for this case, A is 2, M is 4. And in this case, A is 5, M is 3, power is 3. Now, what about algebra? It's nothing but just A times A times A times A times A. So how many times have I written? 1, 2, 3, 4, 5. So it's actually A to the power 5. Then what about another unknown? Another unknown may be y times y times y times y equals, so 1, 2, 3, 4. So it will be y as the base, power 4. And that's it. So this explains what it represents by a to the power of m. Of course, a will not be equals to 0. So this is the rule of thumb. Okay, so with this that you know of, which is the basic, okay, translating numbers to algebra form. Next, we move on to a to the power of m multiplied by a to the power of n equals to a to the power of m plus n. So if you refer back to this example that I have, 2 times 2 equals to 2 squared. 2 times 2 times 2 times 2 equals to 4 squared. So we will have 2 squared times 2 to the power of 4. If we use this formula, it will be 2 to the power of 2 plus 4, which is 2 to the power of 6. Now, does this make sense? So let's look into the basic. So just now, I talked about the base, which is a to the power of m, meaning to say m is the number of times that the base appears. Okay, so a is the number that is appearing. Okay, so if you know this, then let's go to the basic. Okay, so if we refer back to this, what does it mean? It means that number 2 appears 6 times. So if we have 2 times 2 times 2 times 2 times 2 times 2, so over here it appears 4 times, and over here it appears 2 times. So in total it appears 6 times, which is 2 to the power of 6. Okay, so because 1, 2, 3, 4, 5, 6, so it's actually, if you want to word it, can I also translate this 2 to the power of 2 times 2 to the power of 4. So when you see 2 to the power of 2, it's actually this term, multiply by 2 to the power of 4, which is this, is actually equating that you will have to sum up the power, which gives you 2 to the power of 2 plus 4. Then it will in turn gives you power 6. So this explains why the formula is a to the power m times a to the power n equals to a to the power m plus n. So take note, when you are applying this formula, the base is the same. So when the base is the same, power, you add it up. Okay, so we translate this to, if you want to apply the formula, after understanding, it will be a to the power of 2 multiplied by a to the power of 4. It will give you a to the power of 2 plus 4, which is a to the power of 6. Okay, so if you refer back to this, it's the same thing. So if you translate this to unknown a times a times a times a times a times a equals to 1, 2, 3, 4, 5, 6, a to the power of 6. Then if you work it out, it's actually a times a is actually a squared, multiply by one, two, three, 4, a to the power of 4. That's why it is a to the power of 2 plus 4, which is the same as a to the power of 6. So this explains to you why we use this indices of law, a to the power m times a to the power n equals to a m plus n. Okay, next we move on to a to the power m divided by a to the power n equals to a to the power m minus n. So what does this mean? Now, just now we know that 2 times 2 times 2 times 2 equals to 2 to the power of 4. Okay? We also know that 2 to the power of 4 is actually 16. Okay? Now, we also know that two times 2 equals to 4. Sorry. 2 times 2 is actually 2 squared, which is 4. Correct? So if we were to work it out in terms of divide, meaning to say 16 divided by 4, is it equals to 4? Is this equals to 2 squared? So can I say that it's actually 2 to the power of 4 divided by 2 to the power of 2, which is 2 to the power of 4 minus 2, 2 squared. Now what happens if it is 3? Let's see. So if it's 3 times 3 times 3 times 3 times 3 times 3 equals to 3 to the power of 6, which will give you, let me count, okay, now 1 time 2, 3, 4, 5, 6, 7, 2, 9. Okay, then I have 3 times 3 equals to 3 to the power 2, which is 9. So 729 divided by 9, what does it give you? 81. So we know that 729 divided by 81, divide by 9 gives you 81. Okay, so 729 actually refers to 3 to the power of 6 divided by 3 to the power of 2. So 3 to the power of 6 divided by 3 to the power of 2, based on the indices law, is m minus n. Okay, so meaning 3 to the power of 6 minus 2, which is 3 to the power of 4. So let's try out 3 to the power of 4. 1, 2, 3, 4. 81. I'm sorry. Again. 1, 2, 3, 4. It gives you 81. Okay? So 3 to the power of 4 is known to be the same as 81. So how do we represent all these things in terms of algebra? So to translate the first example to algebra is actually a times a times a times a equals to a to the power of 4. Okay, and this one, a times a is actually a to the power of 2. Okay, so this one is actually a to the power of 4 divided by a to the power of 2, which is a to the power of 4 minus 2, a to the power of 2. Okay, next, a times a times a times a times a times a equals to a to the power of 6. So this a can be anything. In this case, this a is 3. In this case, a is 2. Okay, so this one, next one, I'll draw this line to avoid confusion. Okay, so in this case, a times a equals to a squared. So a to the power of 6 divided by a to the power of 2 will actually give you a to the power of 6 minus 4, which is a to the power of 2. Sorry, minus 2. So this is power 2, so minus 2, so a to the power of 4, which is the same as this. Oops, sorry, it went out of screen. Okay, so a to the power of 4 will be equal to same representation. So in this case, my a represents 3. So a equals to 3 in this case. Okay, in this case, my a actually equals to 2. Okay, so this explains to you why a to the power m divided by a to the power n is actually equals to a to the power m minus n. Okay. Next thing that I would like to touch on is a to the power of 0. A to the power of 0 equals to 1. Why is it equals to 1? So just now you learned that a to the power m divided by a to the power n equals to a to the power m minus n. So this one, same base, power minus. So if I have 3 to the power of 2 divided by 3 to the power of 2, can I say that it's 3 to the power of 2 minus 2? So 2 minus 2 equals to 0. So the power will be 0. Okay? Now, we go back to the basic of math. Primary school, you will have learned that if I have 5 divided by 5, the answer is 1. 10 divided by 10, the answer is 1. Okay, so in this case, 3 to the power of 2 divided by 3 to the power of 2. So this one, 3 to the power of 2 is actually 9. Divided by 9, it should give you 1. So this helps to explain why 3 to the power of 0 equals to 1. Okay? Okay? So in this case, it will be 5 to the power 1 divided by 5 to the power 1 is actually 5 to the power 1 minus 1, 5 to the power 0, which is 1. Can you see the relation now? Okay, another one, 10 to the power 1 divided by 10 to the power 1. So the base is actually 10. The power is 1. So since this is minus, okay, the first term here will be here, minus the second term will be here. Okay, equals to 10 to the power 0. So in this case, 1. Same. Okay, so I've proven to you that different base will still give you 1 when the power is 0. Therefore, it concludes that a to the power of 0 equals to 1. Now let's revisit the laws of indices. Now I have covered a few things. I have covered this, which is m times, a to the power m times a to the power n equals to a to the power m plus n. So this one is done with this example. Okay? with this example to illustrate to you. And the next one, which is a to the power of m divided by a to the power n, is actually equals to a to the power m minus n. So this is done, and I link it to a to the power 0 equals to 1. Okay, so in the next video, I will then cover on the other laws of indices. Okay, so revisit what we have covered today. This is what is started off with. Okay, for laws of indices: base, power. Base is the number that is appearing. Power is the number of times that the base appears. Okay, hope you have learned something today, and see you in my next video. Bye bye.